And if and make sure you stay on top of things. Okay. All right. So page 19. I wanted to start this yesterday already, and I didn't want to rush it. Oh, I should before I start. Page 19. So inscribe polygons, right? It's something is written inside, basically. Think of it that way, right? So when you have, in this case, right, I'm going to use a highlighter. When you have diagonals, we call these diagonals, right, inside a polygon, you want to focus on the polygon that surrounds everything, okay? That's what you want to focus on. And immediately count the number of sides, right? So if you count the number of sides of the big polygon, you would say, hey, this has n is equal to 5 here. Okay, so you focus on that because I don't know if you've realized, but there are no numbers here. Not a single angle is given. So you're probably going to have to use polygons for that. Same here, you have your diagonal there, but you're going to focus first and foremost on the big one outside. Okay. If you count these, you have 7 sides, right? 1, 2, 3, 4, 5, 6, 7. N is equal to 7, right? So focus first and foremost on that. Okay. And then you have this diagonal here, if you can write it in. Page 19. Okay, there's a diagonal there. There's a diagonal here. And they form shapes that you should at least recognize one today. This diagonal here formed, first and foremost, we should make sure the assumption is this is a regular pentagon, right? It doesn't work if it's not a regular pentagon. And so this shape up here, it's an isosceles triangle, right? And the one down here, it's also an isosceles. You never thought of isosceles four-sided shapes, did you? But it's actually an isosceles trapezoid. It's under the family of quadrilaterals, right? It's not terribly important that you remember the quadrilateral, but yes, it's an isosceles trapezoid, right? So two shapes are formed due to that diagonal there. And over here, if you look at the heptagon, right, that diagonal cuts it into an isosceles trapezoid. Right? And what do you think this one is going to be called? How many sides does that one have down here? If you count the diagonal itself, so 1, 2, 3, 4, 5. Is it a pentagon? Yes, it is. It's not a regular pentagon, is it? Because this side is definitely longer than all the other ones. It's called an isosceles pentagon. Yes, never thought of that, did you? Isosceles pentagon. And let's make those markings again, right? That we're assuming that all those are the same. And I haven't done this in my original, but I was just thinking that maybe this will help you. We use a different highlighter. If you look at this isosceles triangle up here, I think you would all agree with me that this angle here is the same as this angle down here. I think that isn't a stretch for me to say that. Okay. And same thing here. This base angle here, it's the same. It's going to be the same as that base angle down there. I'm going to use a pink highlighter, whatever color you have. It's all good. But if you look at this isosceles here, you would have to agree that this angle is going to be the same as this angle here. And this angle. You know those pens that have different colors? We need one of those for highlighters, right? Click, 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 click. Anyways. So there it is, right? There's something about those base angles. And by base, I mean the diagonal is my base, right? Like if I were to cut it there, I would put it on the diagonal on the ground like that, right? So there we go. I think that'll help you a little bit. Okay, so watch. I'm gonna now go through all the cutoffs. Like I'm gonna cut this one, for example, and get my isosceles triangle here. I'm going to get the isosceles trapezoid and the pentagon there, and I will show you some, I will give you some important formulas when working with these, okay? So, given that these are the same, right? These two are the same. I'm kind of using the same as the orange up here, right? That is that. To find A, right? Sorry, to find B, I should say. I want you to have a little bit of, you need to use your imagination. This one here, guys, even though this doesn't look quite like it, but this is the interior angle, follow me here. This one up here is the interior angle of the pentagon here, right? And that would follow into here. So this one I can actually find, right? Using the interior angle of a pentagon. For the green one, I bring that in here, and now I'm able to find the base angles, right? So base angles would be 180 minus A in brackets divided by 2. And I will say something about A later. Okay, but for now, just write this one down. So this would be the cutout triangle that just happened up there. Right? That's how I would find the orange angles. Over here for the trapezoid, these ones are the interior angles here. You got to be creative here. You know these two here, or if you want to look at this trapezoid here, these two are two interior angles of this heptagon. And those I could transfer in here. I call them A, right? And so to get these base angles, I would use this formula. B is equal to, what do all angles in a four-sided shape add up to? 360, yeah, there you go. Minus, how many A's am I going to take away from it? 2 A's, you see that? I'm going to take away 2 A's, 2 interior angles from 360, and then that remainder will be split in half. I put brackets because some students type it all in one shot and get the wrong answer. Okay. So that's how you would find the base angles of a trapezoid. Okay, so let's do the orange. I will just make these orange here because I did so up here with this one here, right? The orange. So I just kind of keep it there. And then one more time. Here's my isosceles pentagon. Anybody know what the sum of interior angles of a pentagon would be? Some of you filled in that table maybe. Some of you have it on your study sheet. But you could use yes or no. Sum of a 5-sided would be 5 minus 2 times 180. That's 3 times 180. Some of you are saying 540 already, right? We know that it's 540, all of them combined. That's true for regular or non-regular. So to find B, I will have to start off with the fact that all of them add up to 540. And I'm going to subtract how many A's from it? 3 A's. Okay. Close the brackets. And so when you consider 540 degrees, you take away the 3 A's, and you can be certain that these two are the same. So we can just split that whatever remains, we can split that in half. And voila, you have your base angles. And I'm thinking of another thing right now. Why don't we do this? Yeah, it'll still work. This would be what I call the diagonal, right? The bottom of each of these you should consider as the diagonal, like it has been cut out of that big polygon that we started off with, and then we were right, like now it should technically be dashed. Note to myself, I'll go back. Next year's group will have a dashed line there. Okay. You want to take it again? You're free to do so. Why would you, right? This is your diagonal there. Okay. And this is what I'm going to do now. So you got to be ready for lots of arrows flying all over the place. These A's are the interior angle of the big polygon in which these find themselves in. Okay, so where am I going to do this? The interior angle of a polygon is obviously n minus 2 times 180 divided by n. And this is where the arrows are going to fly, okay? So in a sense, or not, there we go. Did too much marking. Right, so that A in that scenario, this A in that case, as well as that A right there, those are always our the interior angle of the big polygon, right? The interior angle of the big polygon. And I think we can use our green highlighter or whatever you use to do the outline of those polygons up there. Maybe highlight that there. So the fact that they're all isosceles allows us to easily find their base angles. Okay. And the pattern would continue. I get very creative, right? I have software to make a 30-sided polygon if I wanted to, or more, right? It starts to look more like a circle after a while, so I can't use it quite to 30, but it is possible. So this pattern could continue, but these are the most common by far. You might have a bonus question that has more, but so just remember the pattern, how I got these, and you'll be fine. If it had been a hexagon, it would be 720 minus 4a, right? And that pattern just continues. Okay, let's put this to work. Let's put this knowledge to work now. So you might want to keep this kind of open on the side here, not just so you can refer to it as we're doing these questions. Okay. Okay. So calculate the values of the indicated angles, okay? And you see the diagonal. Most of the time it's dashed, but not always. If it's not dashed, you should still always zoom out and focus. Can't even stay within the lines. Right, so if you have that green, if you get the hang of it, students actually have fun with these, okay? So you count 1, 2, 3, 4, 5, 6. So n is equal to 6. So here we have it. So my first order of business will be to find this one here. It happens to be the one they're asking me for anyways. So angle A can just be found by going 6 minus 2 times 180 divided by 6. Interior angle of hexagon. I'm justifying what I'm doing there. So angle A is 120. So 4 times 180 divided by 6. Angle A is 120 degrees. It happened to be the one they're asking me for anyways, but if there had been no variable assigned to it, I would still find it. It's almost your must first step. Okay, I'm going to cut that there. And what do you want to find next? I tend to go to the, hey, B, it's B anyways, but I tend to go to the smallest first. So I'm going to find B here. Angle B, it's an isosceles triangle, right? So I'm going to go 180 minus 120, and I will highlight and explain in a bit, okay? That would be 60 divided by 2, which is 30 degrees. Let's take our, I don't know if you want a pen or something, but yes, this is 120 here, of course. It's 120 basically everywhere. I'm going to put 120 way up here as well. I'm not putting 120 down where the diagonal touches because it might throw us off, right? But it's 120 all along there. And so this 120, right, this 120 actually came from here, okay? That's what in our previous page, that's what I would have called A. That's the interior angle. So I don't know if you want to write down, it's an isosceles triangle, right? You found B there. And I will warn you, there's more than one way of doing these. Okay, right off the bat. The more you find out, the more options you have. Now I'm going to find C. There's the long way and the short way of doing it. Angle C. Let's count this one. This diagonal creates, if you count the diagonal itself, it's 1, 2, 3, 4, 5. This is an isosceles pentagon. Okay. So we could use that formula for pentagon because C is the base angle of this pentagon, correct? If this is the diagonal, then this would be considered the base angle. So I used to highlight that orange, right? So I will maybe just highlight that orange as well. I think B, you all understand what's happening there. But for C, if you call this one, we have a pentagon, which is 540 minus 3 times, there are 3 120s at the top here. You see that? And I'm going to split that in half. I don't know how many times students forget to divide by 2, but please don't be a victim of that, okay? Okay, so angle C, let's do that that part there. 540 minus 360 basically, right? So that's 180 divided by 2, which is 90 degrees. You just found out that it is 90 degrees. This is the long way, in my opinion. Or how else could we have found this? What do we know about this whole angle here? It's 120, right? If you take 120 and subtract b from it, which is 30, we also get 90. You see that? You're smart cookies. You're smart cookies. I wish I would have been as smart as you when I was your age. Would have been a lot easier. 120 minus 30, 90, right? This is b here. This is angle b. Right? So I know the fact that it's 120, I subtract b from it. So there's many ways of getting there if you just look carefully, right? Just look carefully and apply your knowledge, right? Okay. I'm gonna leave it here for a bit and get you to do so no AC, but you're gonna have to do some work. So I will leave question B in your hands for a bit, right? And it's okay to consult with your neighbor as long as you're quiet. You see these ones here coming out, poking out here, dashed? That was what I gave you before, right? This worksheet you got, right? When it peeks out like that, don't be too worried about that. Focus on the solid here. Focus on the solid first and worry about this later. Maybe for now, I actually don't want you to worry about M and N. I just want you to worry about the ones that are there. Okay. All right. Okay, go to town. Give it a try. Touch on one more thing, which is showing whether or not diagonals are parallel. So we're reviewing what we did before, okay? So other than tessellations, which is tiling, nothing will be really new here. I'm just going to open your eyes to it, maybe, right? Okay, so a lot of you are starting with X, which is a good choice because it's an interior angle and you're going to need it anyways. Okay, so we go, I counted 7, right? So if you count the solid lines, 7 sides, right? So it'd be 7 minus 2 times 180 over 7. And that is 5 times 180 over 7, which is 128.57. You should recognize that number, right? So there it is. And I saw some of you doing this, which I actually think it's a great idea. You were saying, hey, I'm going to focus first and foremost on the big polygon that kind of holds all those inscribed shapes, right? And I don't know which one you want to start with. You can go Z or Y. It's up to you. If you do go with Y, then it's a trapezoid, right? So that's 360 minus 2 angles that are 128.57, right? So you either just recognize that or you just look at the formula, right? But it's 2 times 128.57. right? And that will be divided by 2. You can use square brackets if you want to distinguish. So y will be 10286. That's what I get here. And you divide that in half. I'm running out of room there, so y is 5143. And some of you are probably, you did it slightly differently. You got 5142. I know some of you got 5142 because you did it a different way. That's fine. I'll explain to you why. So there it is. That's why. Let's figure out Z here. I'm going to do that here. Angle Z. And I'm just going to go 128.57 because that's the whole thing. Minus Y, angle Y. Okay, I'm showing the work there. So Z is going to be 128.57 minus 51.43. So angle Z is 77.14. And some of you probably got 1.5 because you used the formula of a pentagon. That's fine. You're not going to lose marks when that is the case. Okay, as long as you show me your work, you're fine. Okay. So you could go like this, or, right, let's do it the long way. 540 minus 3 interior angles, right? That is all in a square bracket like that, divided by 2. So angle Z, where is it? Where is it? Here, 154.29 divided by 2. Angle Z gets you 77.15 if you do it this way, right? If you round. They're both acceptable, right? So just as long as you understand and you show understanding. And what happened to M? I kind of used up all my space here. Way to go. It's because I added those angles after. My original didn't have that. Okay. Let's see here. I think I can fit M in here. M is an exterior angle, right? So some of you actually said, hey, I'm just going to go 360 divided by 7, right? Divided by 7. And I think it's the same as one of the, so that's 51.43, right? This is M right here. Exterior angle. Some of you went M is equal to 180 minus 128.57. Yes, that's correct. I actually appreciate if you go your own way, right? Like you figure it out. It's all good. It's consistent. And N, I'm gonna box things in later, but angle N, I'm just gonna go 180 minus 2 of those, because I know that both of these angles are going to be the same. They're both exterior angles, right? So 180 minus 2 times 51.43, that's 77.14. And you notice that it kind of matches an angle that I already have inside that polygon. I will go isosceles triangle. So let's clean this up a bit. I don't like it. Let's see. So we go like this. That's Z. And there's N. There's M, Y, and X. It's all good. It's a bit messy. But, you know, as long as you show me work, I'll find the answers that I'm looking for. I have a feeling that you grasping it, you might still need some practice to avoid small mistakes. But I can like by what you were doing while I walked around, you were on the right track. How's that? Okay. So it may seem crazy, but it's actually just follow the steps. So the homework, you want to see crazy? Just go to 21. So this is your homework for this section. You can handle it, guys. Do not tell yourself, I can't do this, right? One diagonal at a time, right? So what do you have here? A trapezoid, right? And then what do you have here? 1, 2, 3, 4, 5. You have a pentagon there. You see? Ignore this one. Only one diagonal at a time. I hope you know what I'm saying. I could make a shell sign here if I wanted to, right? You should be able to figure it out. And so I kind of combine it all here. Don't do it just yet because I want to cover something else. And then you want to see crazier? There's even crazier, right? But you should be able to handle that. And please contact me. Let me know if you're struggling. I'll help you with it, right? Just reach out. Okay, so that's your homework, which you can start maybe if we get through this in time, then you can start this already. Page 22. Prove if lines are parallel, polygon addition. How's that? Polygon addition. So we know how to come up with angles now. We know how to do that. So this is going to help us figure out whether or not lines are parallel. So look at this particular example. Watch what I'm saying here. Introduce variables as needed. Okay? You are the boss, right? You introduce, it's like, hey, I want to find this one here, but Mr. Dirksen didn't give it a letter. I'm going to give it a letter, right? So let's go and try this. You're using Inscribed shapes, guys. That's what you're using. So let's see, like, hey, they kind of look parallel, but how am I going to show it? Right? Let's focus on one thing at a time. How about we find this angle right here? Let's call this angle X, or ACD, right? Angle ACD, the same thing. What is angle X? It's an interior angle of the pentagon. Focusing on that right now. Because remember, there's 0 numbers. I need to come up with numbers. So this would be n is equal to 5. 5 minus 2 times 180 divided by 5. Let's just cut to the chase. That's 108. We've got that figured out. Let's write that in, shall we? 108 is this angle right there. Okay. Now, that would be step number 1. Like, let's come up with some kind of angle. Now, if these two are the ones that I'm trying to see if they're parallel, this would be the transversal, correct? Right? So if I could maybe find this one here, I could say, hey, alternate interior, right? If I could find this one here, what are these two angles called? Consecutive interior. What would these have to add up to? 180. See? So I'm thinking out loud here. So how am I going to do that? Well, I'm going to introduce a variable here. I'm going to call this y. This one right here. And I know that this is 108 up here, right? That's an isosceles triangle, isn't it? You just learned about that. So angle Y is 180 minus 108 divided by 2. That's the base angle of that isosceles triangle at the top. So that's 72 divided by 2, which is 36. Ooh, what is that? 360? Not quite. 36. Let's write that in, shall we? We're so close. We're so close, but not quite. My approach is going to be, I'm going to figure out this angle right there. I'm going to figure out Z. Mr. Erickson, couldn't I have done that right away? Couldn't I have done Z right away and just look at this trapezoid here and work with that? Yes, you could have. It's up to you, right? Why do you make us do more work? Just cause, right? Z is going to be 108 minus 36, right? I know this whole thing here is 108. I'm just going to take the 36 away from it. And what do you get? 72. Wait a minute, right? So these two are consecutive interior. I need to show that something is true about them, right? So angle X plus angle Z would be 108 plus 72, which is 180. Consecutive interior angles add up to 180. Therefore, AB is indeed parallel to CD. This is your final conclusion, and it must be there to get full marks. Okay. Mr. Erickson, I feel like on a test I'm going to freeze. I'm not going to know what to do. Just do something. Put work all over the place. Make your own conclusion. Show me that something is true about that angle pair, and you're good. You're going to get full marks. But if you jump and just come up with some random numbers, I don't know where you got them from, that's when you're going to have an issue, right? So watch out for that. Some students I've seen, they see this. This is a straight angle. So they go 180 minus 36. They find this. Then they somehow use the 360 and they subtract everything around it to come up with this. And then you have your alternate interior. Sure, you can do that. Like if you feel like you want to do that, be my guest. That's up to you. Okay. I'm going to leave you now. This is it. I'm not going to talk more. So homework is this one down here, right? This one down here. I actually put a bunch of variables in there to help you out. There's one more like this if you want on page 24. Page 22B plus page 24. Let me just check here. Just page 24, look for it, right? Look for it there on page 24. Plus page, what was it? 21? Yeah, 21. So much homework, right? I will post the key to this. If I find an archived video of this, I can post that as well if that's going to help you. Finding C in this case is going to be a bit challenging. Do you want me to give you a hint how to find C? Because C and B are alternate interior, right? Notice that there's a trapezoid here. There's a triangle here. If you find this angle and that angle, you can find C by just subtracting these two from that interior angle of that big polygon. And then, right, and then you find C there. And you need to find this one anyways because you're going to find that one. These are the same. Okay, so there we go. Start wherever you want.